Hello, I'm going to explain you now how to calculate the climb performance of an aircraft in steady flight conditions. And with steady I mean flight at a constant true airspeed. Now the climb performance is either the angle or the vertical speed at which climbs are performed. To calculate climb performance we need equations of motion. Now the simplified equations of motion for this situation are provided over here. If the aircraft is flying steady, there are no accelerations. So the change of airspeed with time and the change of flight path angle with time are zero. This gives us the following equations. These equations have climb angle as a variable, but do not include the rate of climb, whilst rate of climb is typically the most interesting parameter. If I multiply both sides of the first equation with airspeed, however, I will get an equation which does include the climb speed. Airspeed multiplied with the sine of the flight path angle is the rate of climb. Thrust multiplied with the airspeed is the power available. And drag multiplied with airspeed is the power required. Rearranging all of this gives us an equation for the rate of climb. Now before applying this equation, let's try to understand what it means in terms of the physics. Now the power available is the useful energy per second we put into the system. And we get this energy simply by burning fuel, which you can see over here. Now not all energy in the fuel is transferred into power available. Part of it is lost, for example, in terms of heat. Now the power required is the energy per second that is required to overcome aerodynamic drag. Combined, this is the excess power or energy per second. Rate of climb is the change of altitude with time. Now realize that potential energy is altitude multiplied with weight. So the rate of climb reflects the change in potential energy with time. Summarizing, the energy we have in excess is used to increase potential energy of the aircraft. Therefore, the equation is essentially expressing a fundamental physics law, the conservation of energy. Now the three factors in the rate of climb equation also tell us something about the aircraft design. The lighter an aircraft is, the higher the achievable rate of climb. If a plane has low drag, it will have a higher climb rate than the same airplane with a larger drag. And finally, more engine power provides a higher climb rate. Now let's see how you can determine the climb performance of an aircraft at a given airspeed, weight and altitude if you have the propulsion characteristics and the aerodynamic characteristics as a function of airspeed. For a given airspeed, we can read off the difference between maximum power available and power required. Now this value divided by aircraft weight is the maximum climb rate achievable at that specific airspeed. It will be achieved if the pilot applies full power and keeps airspeed constant at the specified value. So, with this diagram, it is fairly straightforward. Climb speed can be determined for all airspeeds. Wherever the two curves are furthest apart, the achievable rate of climb in steady flight is at its maximum. The airspeed at which this occurs is typically near the minimum power required condition. There may be some variations in the results depending on the propulsion system characteristics. Now let's see if we can also calculate it without this diagram in case we know the aerodynamic characteristics and the propulsion system characteristics. And finally also the aircraft weight. So over here I just stated what I know of the aircraft. I know the aerodynamic characteristics, so I know the lift drag polar parameters. I know things like wing surface area and I know what the maximum power available is. So let us try to calculate the maximum rate of climb. Now the equation of motion tells us that lift should be equal to weight, and since we know that lift is CL times a half rho V squared S, that must be equal to the weight. Now the weight is a parameter that is fixed, the wing surface area is given, and realize that the pilot makes sure that he or she flies at a specific airspeed. So V is known, If we consider a specific altitude at which we're flying, then air density is known, and a half is a constant parameter. So based on this, we can compute CL. So CL is a certain value. Now, if I take the lift coefficient, then based on the parabolic lift drag polar, which is CD0 plus K times CL squared, then CD is also a specific value. Now, if we have the drag coefficient, we can calculate the actual drag in terms of newtons. It's CD times a half rho V squared S, and all the parameters here we already know. So now I can compute drag, and if I know the drag, I can also calculate power required, which is drag multiplied with airspeed. So this gives us a specific value and the drag as well. Now with this, I can take the rate of climb equation and state that that is power available, the maximum power available, that gives us the maximum rate of climb, minus power required, divided by the aircraft weight, and this will be a specific value. So for a specific airspeed, I can compute the rate of climb, the maximum rate of climb. So a direct calculation is also possible. Of course, once we have determined the maximum rate of climb for a specific flight speed, we can also calculate the corresponding maximum climb angle. And with this, it is also possible to calculate the horizontal speed, which is the ground speed in case there is no wind. And finally, based on the engine performance characteristics, the instantaneous fuel flow can be computed. It is the thrust level multiplied with the thrust-specific fuel consumption. Concluding, you have just seen how to determine the achievable climb rate or climb angle at a given airspeed for an aircraft of which basic data is provided. The maximum rate of climb typically occurs at a low airspeed, close to or at the condition for minimum power required. And you should realize that the calculations were done for a specific altitude, and this is what we call point performance. The achievable climb rate in steady flight will change gradually if the altitude changes. Now, I recommend to do some practice calculations yourself at this moment.